Good evening, everyone. I'll try to keep this energetic in case the blood sugar issues are getting a little bit low with everybody. Thank you very much for the introduction there. Though General Dynamics is indeed a private company, and we do a lot of work in the private sector, I'm going to talk in some broad context here, and it'll actually have a lot of applicability to government and academic and, more importantly, defense industry. So, 5 key areas that I want to sort of touch on a little bit is I'm going to talk a little bit about the complexity that we're seeing, the evolution of computer networks. Now I'm calling them computer networks, but when I get into that slide, I'm going to explore it a little bit more and you'll see why we actually look at the problem space a little bit larger. I want to get into a little bit the changing dynamics of what's going on in the attack environments and the corresponding changes going on in the defense side of our networks. I want to talk a little bit about sort of the trends that are moving on in the, what I'm going to call the advanced or the automated network defense environment. And then I want to find out with where we, General Dynamics, are working with our partners and with our customers and some of the trends that are going on and some of the things and challenges that we see in that particular space. For those of you who are not familiar with General Dynamics Canada or General Dynamics as a corporate entity, we're actually a defense contractor. And General Dynamics Canada primarily is a systems integrator. So the difference that we take from a lot of the vendors that were up here earlier on today, and a lot of the products and technologies that you're familiar with is that we take a much broader approach. A lot of times we are looking at a system-wide solution approach, so we'll be engaging with a lot of the technologies that specific vendors will bring to the table, leveraging them all together and looking at the problem space on the customer side at a much broader perspective. General Dynamics Canada is actually the lead for the General Dynamics organization internationally. So we will take that General Dynamics brand to Europe, Southeast Asia, Middle East, Australia. The upside with that is that it allows us to work with the problem space throughout the world from different perspectives and being able to leverage off of those different solutions and bring in basically experiences from around those world and bring them back to Canada. Because in fact, one of our primary customers, along with it being Department of National Defense, is actually the Government of Canada. It was interesting hearing a lot of the comments earlier on today about problems with the Government of Canada on the security side. Myself, one of my particular projects is actually working with the Government of Canada as they're defining their sort of objective security architecture, recognizing that entities like Shared Services Canada right now have a challenge because they're bringing in all these disparate systems, but they want to understand where they want to get to and make sure that all these programs, ETI was mentioned earlier on, that they're on the right path and that they basically put in a appropriate and adequate security framework so that going forward, you're going to hear less and less about issues like NRC in the news. So we talk about complexity in the computer networks. And I didn't want to change the word computer networks because I don't want to confuse it too much. But the reality is, computer networks, that's about maybe 1990s, early 2000s. The problem space has changed right now. And what we're looking at, as I like to refer to it as either the information or the business ecosystem. It's no longer just the technology. We've heard the message time and time today. One of your problems is you're going to have to secure your technology, but you've got to make sure that your people, they're aware, that they're trained, that they're not only trained, but that they're actually implementing what they've learned. You've got to make sure that you've got to have the right processes in place. So you've got that mix, those what we refer to as the three-legged stool of the technology, the people, and the processes. And that really forms the basis for what you're going to have to focus on, because that's where the attack vectors are going to come in. If they can't come in through the technology, they'll come in through the people. If they can't come in through the people, they'll identify weaknesses in your processes. The icon on here, the graphic on here, obviously is a little bit defense oriented because General Dynamics is a defense contractor, but the reality is that we're looking at integrated environments, that we're looking at businesses, enterprise, governments, whatever, that are very, very complex, and they have very, very complex operational focuses. So it's no longer just looking at how am I going to defend the network or how am I going to defend the people, the reality is that most organizations don't have technology for technology's sake. They have it to support their business. That whatever their operational focus is, that's what they are worried about. They're not worried about the bits and bytes and the computers and the networking. They're worried about maintaining their business. So when we look at this problem space, we actually have to look at it from an operational and a business perspective. One of the key issues going on with that is that it's no longer sufficient to sort of build that moat. And I know one of the themes was the fortress. But the reality is that information itself no longer is useful within a particular domain. Information is a commodity that needs to be shared. Perhaps in 10 years from now, if I'm giving a talk, we're going to be talking heavily and focusing exclusively on data centricity. That's where the trends are going. We're not there yet, but we're moving down that path. The security will be bound to the information. Right now, we're going there, we're putting in the tools for that, but the reality is we don't have that capability, but we need to treat it. We need to be able to share information with our partners. We need to be able to take information and build on it, fuse it, identify trends, associate metadata, all of that aspect. And that is, again, adding so much more complexity to this problem space. Finally, one of the biggest challenges that I see is this fighting back and forth between the federated model and a consolidated model. Again, shared services, because it was brought up today, the key focus for shared services is to take, amongst other things, the 43 separate classified networks, non-military, in the Government of Canada and consolidate them to one, to take hundreds of data centers to consolidate them into one. Great idea, cost savings, more importantly, business process improvements will come from that. The challenge, of course, though, is that you have just increased the attractiveness for the attackers. So rather than having all these disparate systems, which makes it a challenge for somebody to get in there, they've got to identify where the jewels are, you've put all the jewels under a spotlight. So you've got to make sure that you understand that and you're taking the right approach for doing that. Now, the attack vectors, we all know that stuff. For those of you familiar with the CIA triangle, quick mapping on that stuff. And of course, you've always got to look at it insider, outsider. And the challenge, one of the biggest challenges with that is a lot of times insiders are becoming the threat without even knowing it themselves. Without them knowing it, they have been compromised, whether it's through resources at home. I like the earlier icon, the bring your own disaster. People don't realize what they may have on their smartphones. They get on the corporate network, boom, they've been turned around. So one of the biggest challenges with these networks getting so complex is also the fact that our adversaries are also getting very complex. We heard the number of messages today about multi-state, state actors. They have capabilities as good as or better than those defending the networks. I'm not sure, but there's probably a good chance that there's a conference like this going on in one of these target countries right now where they're doing the exact opposite of us, but they're collectively talking about how are they going to compromise these systems? What tools are available? How can we leverage all that stuff? We know, we've all heard about the concepts of these multi-stage attacks and how they are able to leverage a small weakness here to get onto a more important weakness elsewhere, that they're able to look at the networks, find out something that you may have missed, and bring it all together. Back to that, what I was talking about with the complex network and the dependencies in that aspects, it is very difficult to look at your networks and understand where the weaknesses are. The graphic in the background, for those of you familiar with attack trees, that is a very simplistic attack tree for a 4-computer network running Microsoft Office with a hardened OS. I can't remember which version of Windows it was, but it was a hardened OS. So if you actually look at that, every single one of those blue dots shows a compromise of vulnerability path. And if you can see the lines that bring them all together, if you get in through one of those blue dots, you can start going throughout the entire network. So this is for a 4-computer network. Think about when our enterprises, when you get 10,000 computers, maybe even more. You've got hundreds of applications, legacy applications. You have different types of OSs. Think of how complex those attack graphs get and how difficult it is to actually defend in that kind of an environment. It's, well, as I'm going to get into later on, it's impossible to do it without tools. So one of the other big challenges that's really coming on, and this is something that is really, really prevalent, it's back to what I mentioned earlier on, Companies have investments in IT not to have investments in IT. They have investments in IT because they have a business model, they have a mission, they have an operational focus. So when we're looking at these attack vectors, we have to understand how the attack vectors change when our missions or our operational focus will change. Obviously, with a strong military focus, we look at things a little differently. Anytime you get into a theater, anytime something nefarious is about to happen, as was just announced by the Canadian government with the Canadian forces being deployed overseas, you see a significant increase in the amount of attacks or attempts on the networks. You're also going to see a changeover in what they're focusing on and where those attack vectors will be looking at and how they allocate their resources. So we're all familiar with the SWORD approach. You know, we have tools, we have technologies that will go in there, they will identify a compromise. We've got SOCs that are looking at the networks, they're looking for behavior that is not acceptable. They're looking for activities that are out of the norm. The example of somebody perhaps logging in from home at 3 in the morning and downloading a couple megabytes of data when they've never done that before. So we have tools that can do that stuff, that can react accordingly. They can flag things, they can send up alerts, they can actually, if your tools are effective and your processes and your policies are strong enough, you can proactively shut things down, turn off networks, restrict access to SANs, however. Going forward, we're also taking the approach of what I refer to as the shield. So this is significantly more than just patch management. What this involves is looking at your assets, getting that situation awareness of what you've got from your technology, to your information, to your processes, to your people, identifying the gaps, going through that, identifying where your easiest hits. We actually use a ROI type of analysis on that because companies do not have unlimited resources, whether it's technology, dollars, or people. We don't have unlimited resources to fix all the chinks in the armor, so we've got to focus on the most relevant ones. So in a non-real-time manner, we're able to look at the solutions, we're able to look at the environment, adapt those solutions to the environment, and actually start to implement them. So this is this real reactive and proactive approach. The reactive approach, you're going to be looking to respond within seconds, sometimes within milliseconds. You've got to be able to identify what's going on, shut it down, implement your mitigation strategies. The proactive gives you the advantage that you can have days, you can have months, you can do some significant investments, you can do disruptive, you can take down part of a network, you can actually replace technology. But they work hand in hand. You need to have that proactive to understand what's in your environment and how you can fix it, because sometimes you can actually look at that analytics and identify those courses of action and have them in place so that when an attack happens and you're in that reactive mode, you actually have a pick list. You can pull those things out, or you can even automate it to the point where that if a certain threshold has happened, that mitigation strategy has been deployed. So this is getting into this concept of advanced and automated defense. Again, if you think back 2 slides to that little attack graph that I had on there, magnify that to a network of 10,000 applications, hundreds of interface points to your partners or different organizations, perhaps different security levels, or more importantly, segregation between your mission and your operations systems, your management systems, your legacy. You get a very, very complex environment. So one of the big things that really comes out with this advanced network defense is this concept of this quantitative analysis. There is a lot of work that's being done both in industry and academia on this, with a lot of the algorithms that can go through these networks, that can collect all this information and identify where the problems are, what are the incidents that you need to worry about. How do I even actually get that picture of what the network looks like? We think about it, when you're constantly plugging in, plugging out, you're getting new addresses. How do you, identify and rectify MAC addresses, application signatures? How do I reach beyond a certain network when there's a firewall there that I can't get access? How do I actually know that my partners are protecting their networks when we have shared resources together? Excuse me. So when we are able to do this kind of analysis, when we're able to look at a network that gets quite complex from that graph that I was talking about afterwards, we really get into this model where we can have these complex solutions and understanding which solution makes sense at which time. I think everybody's kind of heard of the detect, defend, plan, act approach. Well, the military obviously likes to have their own acronyms, so they use the OODA Loop. Personally, I like the OODA Loop because it's a lot easier to say, and OODA is kind of a fun word to say. But it's the same premise. You have an understanding, you observe what's there, you have an understanding. You orient it, you figure out what the problem is, and you start to gather information and collect information around that. You decide, you figure out, well, I'm going to dedicate my resources here, I'm going to shut down networks there, isolate users there, segregate data elements in that area, and then you act. You figure out which is the best approach to go forward on that. And obviously, it's a continual loop. When we think back to the previous slide, which had that nice hockey team logo on there. In the SWORD approach, this OODA loop, you've got to exercise this within seconds. You've got a problem space going on. You've got to be able to go through your networks, identify the problem, identify that impacted or compromised area, and be able to respond quickly. Obviously, in a proactive side, you've got a little bit more timelines. Again, we're talking hours, days, perhaps even weeks on for some of the more significant or disruptive types of solutions you'd deploy. Automated defense. There's a lot of research going on in this area. For anybody who keeps track of this, DARPA, I think it was about 12 months ago. DARPA is the big research organization associated with DoD in the States. They have a $2 million bounty for somebody to develop an automated solution. Unfortunately, we're actually doing this for somebody in Canada, so I can't take it and sell it down there because the Canadian government has a fair bit of IP on this. But what we're doing is we're actually working with the government of Canada, building a framework that's going to do this automated, advanced defense of their networks. Particularly, this is focusing within a D&D client, but it's applicable to all of government of Canada. It does take into account a concept of operations in that it understands the business model, it understands the missions that need to be supported, and that sometimes if you deploy a technology solution, it's going to have negative impacts on your business. One of the, probably the most important aspect is this concept of flexibility. There are a number of excellent point solutions out there. I could list off companies, the Dambalas, the Palo Altos, the FireEyes, the Fidelises. You go with them. Every one of them's got a great approach for solving the problem space. Depending on what your problem space looks like, one of them might be a little bit better than the other. But the reality is that they all bring something to the table. So one of the key tenets to this approach for this Armour architecture is this modularity and flexibility so that you can actually swap in these different types of technologies or have them working complementary. And that's been achieved by, if you look at sort of that light green or that middle blue framework in the middle there, this Armour solution, this architecture is based on a framework that allows technologies to come in to share information. This is actually based on the NATO CSER data model. Actually, it's interesting. We work very closely with the NCIA group primarily in Den Haag with NATO on a lot of their cyber defense work. And we're actually one of the lead organizations working with them. For those of you who are not familiar with that particular group within NATO, actually Canada is the lead within the NATO community for developing a lot of the cyber focus and cyber solutions. It's a great opportunity for industry in Canada to get together with NATO and focus in that particular area and expose them to a lot of our approaches and solutions. So with this Armour architecture, as I said, it has this kind of a middle layer or an integration framework that allows all these different technologies to come in there. It is based on many of the standards that are starting to exist or mature within this space. CVSS, OVAL, CVE, Alphabet Soup going on further and further with that. But the basic premise is that you can have this underlying architecture that allows you to leverage the advantages of all these different technologies, and particularly if you have existing technologies. Let's face it, it's not a greenfield environment. They've got technologies deployed. Sometimes they have good effectors and sensors. Sometimes they have others that can be improved upon. Nonetheless, the key tenet with this is that you're able to leverage and share information. So coming out of that, the message from our perspective is that the problem or the key element in solving this problem is not just the technology, it really is an architecture. You have to think bigger than that. Of course, we're a systems integrator, so that's what we do. We do think bigger. Doesn't mean that technology is not part of the solution. It is, but you've got to look at it at a much bigger perspective. And again, adaptability, modularity, You don't want all your security solutions from one particular vendor from a technology perspective, because when that chink gets compromised, your entire aspects are hit. It's nice to sort of divvy it around, not necessarily because one's better than the other, but if I have both, solutions, DLP solutions from vendors 1 and 2 in my system, if one turns out to have been compromised, at least I may have a fallback on that. And the key thing for us, and this is what I was talking about with some of these standards, is information sharing. For those of you who aren't familiar, there's something called the National Vulnerability Database, NVD. Regardless of what you do in your work or not with regards to security, I would suggest you go visit their website, search it up. It's a NIST website. Even if you're just somebody who uses a computer at home, if you went on NVD, you would have found out about Heartbleed before the media found out about it. You would find out about Bash before the media finds out about it. NVD is a wonderful resource that everybody is pretty much contributing to, that identifies weaknesses in technologies, primarily software. A lot of times, again, before, well, I wouldn't say before the attackers find out about it, but at least a lot of times before industry does. So from our perspective, some of the key thrusts of research, R&D that we're doing, and in fact, I'll put this out to anybody in the audience today, if you are interested and you want to talk to me about, we are actually always looking for R&D partners in this space. One of the biggest problems is when you're looking at a situation awareness, trying to understand what's there right now. How do I actually, when I start collecting all that information, how do I reconcile it? How do I normalize it? How do I populate that data model with an accurate picture that's there? Part of that, how am I able to actually reach out into everywhere in the network, all the hosts, all the devices, all of the elements of that network, particularly when we look at the mobile networks, or mobile elements. How am I actually able to reach out and find out what's going on in that particular area? As I was mentioning, one of the key focuses for us is making sure that the approaches that we take focus on the operational aspect. So a lot of research in there. How do you describe a business process in a machine-readable language? How do I be able to share those business processes with other tools and technologies? How do I identify which is the most prevalent one at a particular time of day? Visual intelligence, I was joking with somebody earlier on that big data was the big mantra probably about 24 months ago in cyber. Everybody was doing big data. If you had a experience with Hadoop, you were in. But the reality is that big data is there. It's now part of the ecosystem. But when we start overloading the operators, there will always be operators, but when you start overloading them, how do I make the information relevant to them? How do I make the tools for them to be able to decipher through basically the chaff to find the important stuff? A lot of research going on in the course of action and incident analysis. When I'm looking at incidents, what's a false positive? What's a false negative? How do I determine what the impact of that? How do I relate that to the course of actions? And how do I figure out in these complex attack trees which course of actions to roll my resources into? And continuous vigilance. Basically, how do you do this in a continual basis when you're dealing with so much churn, so much volatility? And the interesting or challenging, depending on how you look at it, way is that this churn volatility is actually increasing. It's not just high already, it's increasing, and it's increasing at a faster rate. That last little graphic up on there just reinforces the fact that this is not a problem for any one individual to solve. This is going to be a shared environment, whether it's within a national environment like Canada, between government, industry, and academia, or within our partners, within the NATO community, Five Eyes, or just, as was mentioned earlier on, there's the need for the large cyber players to share information. There's a need for everybody to share information. So the last slide I just wanted to leave you guys with is these are a number of initiatives that are going on in this space that are very relevant to actually what's going on in Canada, what's going on on a couple of my projects here, but more importantly, going on within the cyberspace. NATO is doing a lot of really interesting work on the research end of this and applying that research. One of their biggest projects is the CDXI, the exchange environment, where you're going to get all of the NATO countries being able to share all of this extremely rapidly changing cyber defense information in a real-time format so that when an attack occurs in one environment, they can share it with everybody else. Thank you.